Good day. I'm Miss Resi Rodriga. Today we're going to discuss about logarithmic functions. Let's start with the different dinosaurs discovered in these different countries around the world. So let's start with Tyrannosaurus Rex, discovered in the United States or North America. Next is along Europe, we have Iguanodon, located at United Kingdom. Third one is Sinosauropteryx in China, along Asia. Next is Argentinosaurus, located along South America of Argentina. Next is Spinosaurus, discovered in Morocco, part of Africa. And the last is Titanosaur, located in Australia. Dinosaurs have always been fascinating animals. To some people, this is reflected in the different movies and television shows that features them, such as Jurassic Park, Jurassic World, and so on and so forth. So it is believed that these creatures existed during the Triassic period between 251 million years ago. Scientists discovered their existence from fossils that were excavated by archaeologists. These fossils then underwent carbon dating to determine their age. So what is carbon dating? Carbon dating is in essence the process of verifying the age of material by determining the amount of the carbon-14 in the material. Carbon-14 is an isotope of carbon that undergoes radioactive decay. Thus, the age of the fossil can be calculated using exponential functions that we discussed last meeting. So today, let's have the inverse of the exponential function, which is called logarithmic function. So what are the different forms of exponential and logarithmic function? So let's have the transformation of the form x is equal to b raised to y for exponential form. For logarithmic form, we have y is equal to log of b of x, or can be read as y equals the logarithm of x to the base b. So let's define logarithmic function. For all the positive real numbers x and b, where b is not equal to 1, the inverse of the exponential function y is equal to b raised to x is the logarithmic function. Y is equal to log of b of x, or f of x is equal to log of b of x. Next, the definition of logarithmic function emphasizes that b is greater than 0 and x is greater than 0. Thus, logarithmic is defined only for positive real numbers. Okay, so let's have the next slide. Exponential equation transformed to logarithmic function. So 2 raised to 4 is equal to 16. When you're going to transform this to logarithmic, it's log of 2 of 16 is equal to 4. For exponential equation, 5 raised to 4 is equal to 625. We have log of 5 625 is equal to 4 for logarithmic function. For exponential equation, we have 10 raised to 6 is equal to 1 million. The logarithmic function form is log of 10 of 1 million is equal to 6. Next, for 1 half raised to 5 is equal to 1 over 32. The logarithmic function for that is log of 1 half 1 over 32 is equal to 5. For exponential equation, 6 raised to 1 over 6 is equal to 2. The logarithmic function form is log of 64 of 2 is equal to 1/6. Okay. The next slide is about the different steps in evaluating logarithms. The first step is expressing equation in exponential form. Next, after expressing in exponential form, we need to solve the exponential equation. So how do we solve the exponential equation? Express both sides of the equation using the same base. We can use the property b raised to x is equal to b raised to y. Therefore, x is equal to y. Okay, so let's have example number 1. Evaluate log of 3 of 81. First, let y is equal to log of 3 of 81. So, we need to transform the logarithm to exponential. So, we have 3 raised to y is equal to 81. Next, for the second step, we need to have the same basis of 3. So, 3 raised to y is equal to 3 raised to 4, because 3 raised to 4 is also 81. Therefore, applying the property, we have y is equal to 4. For second example, let's evaluate log of 5 of 1 over 25. First, let y is equal to log of 5 of 1 over 25. Let's apply the first step. We need to transform logarithmic to exponential. Therefore, the exponential form is 5 raised to y is equal to 1 over 25. For the second step, we need to have same base of 5. So, 5 raised to y is equal to 5 raised to negative 2. Because 5 raised to negative 2 is also 1 over 25. So, the final answer is y is equal to negative 2, applying the property b raised to x is equal to b raised to 1. Next, let's have steps in solving for the base in the equation. So, how will you solve for the b? Number 1, let's express in exponential form. Next is solving the exponential form or equation by squaring both sides of the equation. So, let's apply that. So, example, log of b of 10 is equal to 1/2. So, let log of b of 10 is equal to 1/2. b raised to 1/2 is equal to 10. Applying the second step, square of both sides, b raised to 1/2 raised to 2 is equal to 10 raised to 2. So we have b raised to 1 or just b is equal to 10 raised to 2 is 100. Okay, so let's have the graphing of logarithmic function. The first step in graphing is expressing in exponential form. After transforming to exponential form, we need to make the table of values. How to make the table of values? First, we need to choose the values for y and solve for the corresponding values of x. This is easier than choosing values for x and solving for the corresponding values of y. And for the last step, we need to plot the points shown in the table of values on the Cartesian plane. And then we will connect the points using the smooth curve. Now let's have example number 1. Let's graph f of x is equal to log of 2 of x. F of x is equal to log of 2 of x. Let's change f of x to y is equal to log of 2 of x. And then transform logarithmic to exponential. We have 2 raised to y is equal to x. Next is to make the table of values. So let's assign negative 3, negative 2, negative 1, 0, 1, 2, and 3 for y, or also f of x. To solve for the x values, we just substitute negative 3 to the equation 2 raised to y is equal to x. So we have 1/8. Next, 2 raised to negative 2 is equal to 1/4. 2 raised to negative 1 is equal to 1/2. 2 raised to 0 is positive 1. 2 raised to 1 is positive 2. 2 raised to 2 is equal to positive 4. And 2 raised to 3 is equal to positive 8. As you can see, the function here is a 1-to-1, and the function is also increasing because positive 2, or the base, is greater than positive 1. So from 1/8 it becomes positive 8. The domain, or the x, consists of all positive real numbers. And lastly, the range consists of the real numbers, 0, positive integers, and negative integers. For the graph, as you can see, the graph passes through 0 and 1. The graph is also asymptotic to the y-axis, is a vertical asymptote. So let's have the second example. Graph f of x is equal to log of 1/2 of x. F of x is equal to log of 1/2 of x. Let's change f of x to y is equal to log of 1/2 of x. Then transform logarithmic to exponential function. So 1/2 raised to y is equal to x. So that's our equation. From the equation, let's make the table of values. Let's assign negative 3, negative 2, negative 1, 0, 1, 2, and 3 for f of x or y. in the equation 1/2 raised to y is equal to x. So therefore, 1/2 raised to -3, we have positive 8. 1/2 raised to -2 is equal to positive 4. Next, 1/2 raised to -1 is equal to positive 2. Next, 1/2 raised to 0 is positive 1. The next is 1/2 raised to positive 1 is 1/2. Second to the last is 1/2 raised to positive 2. We have 1/4. And the last, 1/2 raised to 3 is equal to 1/8. So as you can see, the function here is also 1-to-1. But if you will look at the base, which is 1/2, it is in between 0 and 1. Therefore, the x is decreasing. So from 8, it becomes positive 1/8. And then the domain is consists of all positive real numbers. And the last is the range. Consists of real numbers. It can be 0, positive integers, or negative integers. Next, for the graph, as you can see, it passes through 0 and 1. So the graph here is asymptotic to the y-axis. It is also a vertical asymptote. Okay, so to summarize the different properties of logarithmic function, we have the function is always 1-to-1. The graph passes through 0 and 1. Third, the graph is asymptotic to the y-axis, is a vertical asymptote. Fourth, the function is increasing when the base is greater than 1, while the function is decreasing when b, or the base, is in between 0 and 1. Second to the last is the domain, consists of all positive real numbers. And for the last property, the range is consists of all real numbers. Okay, so for your activity for today, you're going to evaluate each logarithm in your notebook. So number 1, log of 2 of 4. Number 2, log of 25 of 5. Number 3, log of 64 of 64. 4, log of 1/3 of 19. And number 5, log of 1/3 and 1. So if you have questions, just message me in the MS Teams. I hope you learned something today. So thank you very much for listening, and good day.